6.2 polynomial practice. Is the function a polynomial function? If it is, write in standard form and identify the degree and the leading coefficient. This first problem is a polynomial function. I'm looking at the powers, and we can't have anything that's a negative power, and they have to be whole numbers. And that is the case here. So no fractions, no decimals, no square root powers. It's all about the powers. Now we need to put it in standard form. So that means the highest power in the term with it has to go first. So negative 2x to the third goes first. The next highest degree is to the power of 2, and that's a positive 3x to the power of 2. And then, so I'm taking care of these two, and then the last term is this 4x to the power of 1. You don't need to write the power of 1, but you need to know it is the power of 1. So that's the function rewritten in standard form. Identify the degree. The degree is the highest power, which is 3, or the highest exponent. The leading coefficient is the coefficient tied to that term with the highest power, so it's negative 2. So it's all right here. Here, this is not going to be a polynomial function because it has a negative exponent. So this is the prob. So it's not a function, polynomial function. Not a polyfunction. This one looks good. It starts with the correct or highest degree term, so 2x to the fifth. Then this thing needs to go next. It's a positive 7x squared. This minus sign affects the 3, and that's the last term that needs to get put onto this polynomial function. So the degree is the highest power or exponent you see, that's the 5, and the leading coefficient is the coefficient of that term, so it's 2. Use direct substitution to evaluate the polynomial function for the given value of x. Use a calculator, por favor. So we're substituting negative 3 in place of x. Make sure when you do this you use parentheses around your substitution. You can type that just as it is there. So f of negative 3, when the function, when the x value is negative 3, y is, I'm getting negative 7 in my head, but I'm not using a calculator, full disclosure, which I should be. Bum, 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 bum. Yeah, that looks good. Number 5, we're plugging in negative 2 for x. So negative 3 times parentheses negative 2 to the fourth plus 2 times negative 2 squared minus 3 times negative 2 plus 4. According to Miss Scott, she thinks that this is going to equal negative 30. Is that what your calculator says? Awesome. And then last but not least, number 6, we're plugging in 3 for x. So when we plug in 3 for x, we get, so this is what I'm writing down is, I don't know if you need to write this down, but this is what you need to type into your calculator. That's how it needs to look in your calculator. And when you do that, according to Ms. Scott, you get 74. The function, when x is 3, the input is 3, the output is 74. All right. The cool thing about synthetic substitution is you can probably do this without a calculator now. So remember, we write down, we make this funny box, and we write down all of the coefficients of the terms, and it needs to be in standard form. Notice there are no powers. Oops. There are no powers missing here, so we don't need to put any zeros down. If you had a power missing, you'd put a 0 down in place of it for the coefficient. I'm sure that'll come up in a little bit. This, the number that we would substitute in for x, comes out in front. First process is to drop down the leading coefficient, which is 2 here. And now we multiply. We're always taking this value and multiplying it with this row. So 4 times 2 is 8. And then we add negative 3. So then we're always adding these 2 rows. Negative 3 plus 8 is 5. And then again, I multiply 4 times 5, which gives me 20. I don't know why I'm coloring it this way, but I just am. Then we add 4 and 20, which is 24. And then, just to pick a new color, we take 4 times 24, which is 96. 96. Do as I say, not as I do. 96. There we go. And then we add these together, and we get 98. The crazy thing is, if you would have done f of 4, evaluate the function when x is 4, and done the substitution that we just did earlier in your calculator, you would get 98. Isn't that crazy? All right, let's try this next one. Maybe I won't use all the different colors. Maybe that's kind of goofy. So negative 2 comes down. That's x to the 4. X to the 3 has a coefficient of 3. X to the 2 has a coefficient of negative 5. X to the 1 has a coefficient of 2. X to the 0, that's really negative 6x to the 0, has a coefficient of negative 6. Take what you would substitute in, that's going to become your multiplier. That goes out in front, and so we're going to be multiplying it with the values down here. How do we get our first value? Well, we just bring it down. So we get negative 2. Now I take negative 2 times 2, which is negative 4. And then 3 plus negative 4 is negative 1. Now take 2 times negative 1 is negative 2. Add them together, you get negative 7. Take negative 7 times 2, you get negative 14. Add those together, you get negative 12. 2 times negative 12 is negative 24. Add them together, you get negative 30. I am done. So that means that when you plug in negative 2 for x, you get negative 30 out. Boom. Well, I'm afraid that Miss Scott disagrees with me there, and I did this earlier and I got her answer, which is negative 86. So I'm going to quickly check my work. Negative 4. Did I copy something down wrong? Anyway, she got negative 86. I'm not seeing a booger right now, but I'm pretty sure I did. Make a mistake somewhere. I'll come back to it or something. I don't know. That's too bad. Oh, I got my work on me. And I did it on paper. Let's get this taken care of. Oh! Ha! Ha! That's silly. You guys see it? God darn it. So this was supposed to be a negative 2 right here. And what did I do? 2. Which I bet if you plugged in 2, you'd get negative 30. And sure enough, I wrote down negative 2 right here, but that's not true. That's a lie. F of 2 is negative 30, if I did my math right. So let me do this one more time. But boy, it hurts to, like, if this is a test, folks, and you're running out of time, I wouldn't delete everything if I were you. You know, just obviously Mr. P knows the process. So do you, if you did this kind of work. It's just a silly one. But you probably don't want that written down for your work. And you're like, oh man, I used all my paper. You guys probably got space to do it again. I don't know. Here we go. Let's try one more time. And because it's good to multiply by a negative, it's good to get some practice here. Remember, when you multiply by a negative, it makes the value opposite of what it was. I'll show you what I mean. So I'm going to take negative 2 times negative 2. A negative times a negative is a positive. So the sign here, when I multiply by a negative out here, the sign of my product better be opposite of that. And that's a good thing to always check because it's a very common mistake. So now we add, we get 7. Now I'm going to take a negative 2 times a positive 7. So my answer needs to be negative because the opposite of positive is negative. So we get negative 14. Add them, we get negative 19. Now a negative times a negative is a positive. If it helps to put a plus sign, do it. That's positive 38. Add them, you get 40. Negative 2 times 40. Well, it's going to be the opposite of a positive, which is a negative. So you get negative 80. Add them together, you get negative 86. So the true story is when x is negative 2, x is negative 86. Sorry about that goof up, folks. All right, here, when I start to do my synthetic substitution, I need to realize that I'm missing an x to the third term. I have x to the 2, x to the 1, and x to the 0. So I need to put a 0 in place of this green dot that I just put up there. I'm putting in a positive 1 as my multiplier. If I multiply with this row, I've got negative 5. I've got 0, and then 3, 2, and negative 5. So bring down your leading coefficient, multiply it with the 1, you get negative 5. Add them together, you get negative 5. Multiply them together, you get negative 5. Add them, you get -2. Multiply them, you get -2. Add these together, you get 0. Take the 0, multiply it with the 1. You get 0. Add them together, you get -5. I went fast on that one. I'm sorry, folks. I'll do the next one slower, I promise. So when you plug in 1 for x, you get -5. All right, this next one, I don't have an x to the 5, x to the 5th. I don't have an x to the 4th. I don't have an x to the 3rd. I don't have an x to the 2nd. So there's lots of zeros there that I need to put in. So I'm substituting in, or I'm substituting in a 2, so that's my multiplier, because x equals 2. My coefficients are 1, then a 0 for the x to the 5th, a 0 for the x to the 4th, a 0 for the x to the 3rd, a 0 for the x squared, but I do have an x term, and the coefficient's 3, and I do have a constant, or a plain old number, and that is a 4. So drop the 1 down, multiply anything in this row by this multiplier, so 2 times 1 is 2. Now I add these two numbers together, and I get 2. I take this sum, this answer, and I multiply it with that, which is 4. Add these two together, you get 4. Take that answer to the addition and multiply it by that, which is 4 times 2 is 8. Add these two numbers together, you get 8. Take that answer, multiply it by the 2. Add these two together. Take that answer, multiply it by the 2. You get 32. Add these together. Multiply it by the 2. Add these together. Oof, you get 74. So that means that when x is 2, y is 74. Hip hip, hooray.